Hello, hello. Good day, everyone. Today I'm gonna be working on cast again. Right, last time we were doing the Ludum there, and we were making the game for it, the Mega Honk, using minicast. And today, what I want to do is to add algebraic effects. Hitting algebraic effects. Let's see. To cast and mini cast. I think we're going to have it in both of those. Algebraic effects. How do I describe it? In short, how about we look somewhere? Algebraic effects. For the rest of us. That's a little bit too long. Bum, 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 bum. Fact, I don't know. Maybe I just say something like this: are a as I understand it right now, it's a type safe mechanism for delimited continuations. We can use them to implement sync await stuff. For example, I don't know. Let's do something like that. Hello, Nerdzel. Hi. All right, we're back to cast. But I think I'm going to start with the mini cast. Right. So like, I think minicast is mostly ready, and the effect is basically the last feature that I need to like to do everything that I want to. I think maybe. I'm perhaps interested in a little playtest. Let's do it in a little later, if you're okay with that. Maybe. I mean, or I can start with it and then we go into the effects before I start doing anything. What am I supposed to do? Just go to your Steam page? You have not done it yet? All right. There's only a demo. Do you want to update the demo? Beta branch of the demo? Interesting. You don't have the demo, the beta yet, it seems. All right, fine. So we are going to be doing the effects. And what I'm going to be doing is I'm going to compile the effects to C code. That's the whole thing. So how about we start with a little example of what we want to achieve? Maybe. What features does Minicast have now? I don't know. What is the last time you... I didn't really add anything since I was doing the Ludum there. Which is a while ago, I guess. When was Ludum there? The Ludum there is over, by the way. I think, oh, yeah. Also, since you, maybe if you're interested in that, there is my bot working? Over here, right? Yeah. I think after the Ludum there, the only thing that I did is I updated the website. If we go to the docs and we go to the minicast over here, there is, if I did not forget about anything, the features are basically all listed here. And we're going to add the effects to it. Is unwindings there is not like a dedicated section about unwinding, but I think I should about unwinding and the effects. We should add that. Yeah. The effects going to cover memory safety? Not yet. No, we don't do the safety yet. But I mean, in the future, the idea is that, yes, the effect is like weird, because I have the context system, right? And the context system is what a lot of the usually the languages, they just like market the algebraic effects in general. And but a lot of the uses of the effects is literally just the context system. The reason I'm adding the effects specifically is when we want to do async, when we do want like coroutines and stuff, so that we can pause and resume later. That's the important distinction that my current context system cannot do. Yeah. But for safety, I'm supposed to use the so like basically the effect handler is going to be a context, and we are going but the thing that is supposed to be typed is the context system, I guess, mostly, if that makes sense. Yeah, and in terms of memory safety, there is this rough plan, which I don't know when I'm going to get into, is where when you want to mutate a variable, you would need to like to have the capability of mutation, basically, right? Because the context system is the capability system, is what it's called in other languages sometimes. So we have the capability of mutating, but right now we don't have that. That's in the future. Hello, Brainoid. So I want to do just a little example here, right? What is the simplest example of something that requires an async and await and coroutines and effects? We can do like just a generator, for example. Maybe. I don't know. Let's see. So let's say that we have the generator, right? So this is supposed to be a function that generates integers, right? Timeout. Timeout is another one, right? Yeah. Just sleeping, I guess. Could be done like that. We can generate and after a timeout, I guess, also. Right? So what this like an alternative in Rust doesn't. Rust has the generators actually, right? I never used them. What is the other languages? I don't know. Let's not have any example in another language. We basically want to yield the numbers, right? We want something like yielding. Yield I, you know, and then we say that I int is 0, right? And then we have a loop, you know, and we yield I, and we say I is equal to add I1, right? Like that. And then we call the generator. Let's just do this for now. Let's start by saying that yield is a function that takes the int, and I'm just going to print. Do we have print? Yeah, we have print. That's an int 32. Let's do print. Just regular int. Int is also an int 32, right? For me, anyway. So I was just doing print int x for now. Int string yielding print string /n. Let's also say if greater or equal. If I is greater or equal than 10, then I just want to break this, right? Unwindable function. I'm just going to unwind function like that. So we like return from this function. We only generate 10 numbers. Let's do that. How do I do this? Just minicast test mini generator mks. Just no, we just do just C, right? Because this is the mini cast compiling. Okay, there we go. Right, so we are yielding 0, yielding 1, yielding 2, 3, 4, 5, 10. Right, but this is obviously not having anything to do with the generators. I'm just calling a function here. So what we want to do is when we yield here, right? Or let's say, how do we want to use this, right? How do you use the generators usually? You say that you have the generator. Let's call this doGen maybe, and then we have the generator is something. No, not exactly this function, but we're going to somehow create the generator, right? And then we say generator next, right? So we convert this like function into a value basically, and the current state of execution of the function is stored in the value. That's like what we want to have, right? We don't have methods though, so let me think, how should this look even first? I have not really thought much before starting the stream. But we want basically something similar to the unwindable block. Unwindable block allows you to go back and like basically stop executing and go back to this block, right? And what the effects allow you to do is you basically can go up the stack and then you can go back in, basically, right? That's literally it. You pause the execution and you resume later. So I think we do something like, I don't know, let's say handle effect. Let's say handle effect. Handle effect. So we will have the yielding as a part. Let's say before I'm yielding, I'm going to print this over here. Right, and then the actual yield is here. Coco's runtime somehow enabling its effect system was what I hoped would make something like a common runtime for the source languages more viable. I don't think Coco's runtime has to do anything with the effect system, though. You are talking about like the Perseus stuff. That's just the garbage collector, though. No, is there anything like special there? Hello, Nadia. I didn't really like look into the implementation of Coca. I thought Perseus is just the garbage collector, though. Perseus, garbage-free reference counting with like it's about managing the memory. What I'm planning to do for my language is the Rust like borrow checker, which doesn't need this anyway. It is garbage-free though too, right? Like I should probably like read about this more in detail though, because it's probably useful. But I don't like this thing, for example, the functional but in place. I'm not making a functional language, I think. Or I mean, what I mean is I'm making a combination of a functional and imperative language, which is what if the effects basically allow you to do. They like merge the two paradigms in one. Because I don't know, like this is a good hacks and stuff, but in order to be efficient, I think it is better to explicitly like as a programmer, having explicit mutation is better for understanding the performance characteristics of your code, maybe. Is what I'm saying. Because when you see the function that like is instead of written in functional style, you basically rely on the optimizations here. I'm not sure what you're talking about exactly. You was hoping that it would make something like a common runtime for the source languages more viable. I'm not sure what exactly you mean by that. Yeah, and I think this has this doesn't really like this is orthogonal to the algebraic effects too. You can construct values in place on the heap in the final version of cast. It is not done. I need to like finish figuring it out, but roughly the idea of constructing in place is just having the out pointers. I only talked about it, I never like put it into the thing. But imagine if that you have an out pointer, which you basically must initialize. So this would need linear types in the language too. This is basically a reference to uninitialized data, right? And you have to initialize it. And the borrow checker would like similarly check that it would be initialized. And there's two ways to use it. You either like put a value there, or you like split it into multiple sub-values by destructuring. Yeah, it's basically going to be similar to C, but in a safe way, is the idea. So you would still write something like allocate, right? And this would return the like pointer, right? So this is allocating the data that is uninitialized, but to get like the stuff, but like the checker would make sure that you actually initialize it too. That's like the rough idea. We are going to get there. I'm not focusing on the safety things yet. Those are only present in the rough ideas. There is this idea. There is also the so we are basing on the Rust borrow checker. There is the ghost cell, which is going to be also a big part of it. We are separating the data from permissions, and the permission is going to be passed through the context system. This is a zero-sized type, which is going to be optimized away, but it's going to be all like, yeah. This is all a rough idea though, because I never got into actually implementing that. I don't think, is there any other like language, like there is not a lot of languages with in-place construction though, right? Well, I mean, when you say in-place construction, you literally just need to have the place first, so that place is represented by the pointer, right? So you need to have a pointer which is not initialized, right? Which is like, I'm just doing it in the explicit way. I'm just going to do it in the explicit way. Just like C, but in a memory safe way. It's the idea, yes. All right, let me go back to the this example. I'm just trying to figure out what I want to write here. I don't have the syntax for it yet, but we want something where we handle the effect. The effect will be needed to be named. So if we just follow the Coca example, we would have something like effect. Effect. So the generation is the effect, right? We have the name for it. I think if we follow the current idea, then we say gen is effect, I guess, like that. And we say that we have the yield, which is... and this can be generic, I guess, too. X, T. And we return nothing, right? I think this. So... yeah, and over here we handle the effect gen, and we're generating ints, right? Hello, penguin. Any language with references or pointers can do it like you said, but there is always an idiomatic or preferred way, which in Rust's case is lol compiler decides. Yeah. Yeah, I think, like... we'll have to see. Right, we'll have to see, but I think in this case, like if you want to guarantee the things like that, you want to be explicit about it, and Rust semantic, not semantic, Rust's idiomatic solution is not the explicit one, but it is relying on the compiler, which I don't like. Yeah, let me not think about this too much right now. We'll get to it. Rust placement functions. What is the Rust placement functions? Did I see that? Rust placement. placement new. Can you talk about any specific one? Like, for example, if I want to initialize something in the vector, right? There would be a method in the vec. Like the alternative of what? In C++, that would be in place back, and you pass the arguments to the constructor of the element so that you construct it in place, I think, is how it's done in C++. Is that right? It doesn't exist? Oh, it's just in the blog. Okay. I don't know if I've seen this. Actually, I didn't. No, I think I saw that. Yeah. Yeah. Placing, yeah, in the colors frame. Yeah, I don't like this because, like, what if you already have a place? It's not always in the color stack frame, because sometimes I want it to be constructed not on the, like, when they say color frame, they mean the stack frame, right? And we don't want it to be constructed on the stack at all. We want sometimes it to be constructed on the heap, right? So which is why, like, explicitly telling, I mean, maybe if it's a placing function that you would be able to pass the pointer to it, and that would be like the implicit argument here or something. It mentions heap2 here. Well, yeah, there you go. You have like the reference and stuff. To uninitialized. Dun, 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 dun. I'll read that later. But as I see here, it is just a desugar. It's desugaring into exactly what I was going to do anyway, right? So when you are constructing a new object, you basically have a the pointer to uninitialized data, literally. But that's just a desugaring. Whether we want the sugar for it is another question, I guess. But I will start with the explicit one at least, and then we'll see from there. All right, we want to handle effect to generate int. So we know that generate int needs to have a yield. So we say that yield is and we say here x int. So when we are handling the effects, what's going to happen is that we're going to have an extra thing called continuation. Do I need to name it here? I think I might want to name it. Right? Maybe. Let's take a look at Coca and their syntax. Do they explicitly name the continuation or not? They don't name, like, they have it available as the resume inside automatically, right? So it is, I mean, that is fine, probably, actually. That is probably fine, actually. Like, yeah, basically we just have this, but we have a hidden argument, the implicit argument, which is the continuation, right? We'll have the, let's say k is a continuation, which is what we call with the result value to continue the captured continuation. So that would be like that. And what is the return value of the continuation? That is where the return type of this is the return type of this entire expression, basically. Of the entire expression, where we handle this. Yeah, we need to like handle and do something with the handler. Yes, so the type of this expression is the type that we return here. Should it be like what I do and then I handle below? It doesn't really matter. They say with this, do that, basically, right? In COCOM. I want to not call it K. I want to call it something else. What do you think about vibe coding? I don't know. I don't really think about it. Not interested. We can just say continuation. Or they call it resume in COCOM. This is going to return the result type. So if this is the result type, whatever R is, we have that. So the simplest thing that we can do is we can just resume with no arguments immediately, right? Then it would be no different than just calling the function yield. And now, instead of calling the function yield directly, what we're going to do, I mean, we can also do it inside of the yield. We can say something. So we will have the handler for the effect to be passed, and the context system is the idea right now. So I will say current generator of integers. That gives me the value of the handler, and then we do the yield to that handler using the x. That's and that's it. So we could do that inside here directly, or inside of another function, it doesn't matter. With effect, I don't know. We'll think about the syntax. I don't like the effect being the keyword, so I will do an at before it. So so the syntax in general is this: we say with effect, the name of the effect, then the different, what do they call them? The operations of the effect, maybe. And then the actual body. So over here, we just call the function that uses this effect, which is the doGen function, right? Okay, I think if we start with that, then we can build on top of it. Let me do the syntax first. So we want to have the effect type. It is going to be, I guess, similar to struct. So we have effect 2.5. There's going to be effect def, right? And then we will have the expression, which is the delimited continuation. Now, so we say with let's inject context. It's going to be similar to that, I suppose. Syntax handle effect. We say with effect, and this is going to be effect. So this is the type of the effect, and then after that we do the handler, and then we say do, and then we say body, right? I think that's the syntax. Let's try restarting the language server. See if it works. Can finish parsing. Why not? Oh, resume. Resume needs to be... Yeah. Okay. Resume is also a keyword, similar to the context, I guess. So this is going to be the continuation, which let's call it resume. Sure. I don't know. We might change the specific syntax later. Okay, there we go. Syntax is being parsed. I think what we want to do... Do I finish the example first? Or do we start implementing it already? But yeah, basically the idea is that we have this expression, right? Which is we just do this block and we try to compute this. But while we are computing this, we might want to do some operation which requires pausing the execution of the code in this block. So in this case, we're going to pause and we get a continuation object in the form of this resume thing, right? And we can store it in a data structure to resume later, which is how we implement async, literally. And this represents the continuation from the point where we paused to the end of this expression, which is why this is a delimited continuation. Let's actually try to convert this into, like, so basically we want to convert generator to iterator, right? Generator to iterator, somehow, right? So a generator is a function that is doing the yielding, but an iterator is an object which we can query the next item from. So let's say that we have iterator, that's going to be a struct, right, which we can get the next method from, the next item from, which is just a function returning an optional t, right? That's all. That's what we want to get. What's an option? Option is a struct. Let's just do a simple one. We don't have the ADTs in minicast. Let's just say is sum is a boolean, and value is t, which is going to be uninitialized in case this is none. Right? So generator to iterator. What is the generator? Generator is just a function returning nothing, which uses the effect of the generation. But since this is minicast, I'm not going to have it in the type definition, actually. Right? I mean, can I have this in the in minicast to be also be typed? I don't know. We'll think about it. Let's start with untyped effects. So it would be just undefined behavior if you try to perform an effect outside of a handler without having the handler. Low goes up. Right, so we have the generator. This returns iterator t, right? That's also is a generic. If we want. Well, I mean, don't I just say this? No, not really. I think we want to create an object where the next is already a function. So I'm going to like capture this. Right? And so when we call for the next one, we're actually only then we're going to actually call the generator. And if the generator, so if the generator basically has finished, so if we reach the end of this block, it means that there is no generation happened, well, then we will just return none, right? Then we will just return none. So this returns option t, right? So this returns is sum is false and value is uninitialized. Let's return none t. We can do like that. None and sum is just the functions to construct the thing. Right, so we return none, indicating that we have finished. And if I have... Yeah, so over here, here's what we're going to do. If... I'm going to return some x here, right? But I need to store the resumption to be called later. And since the resume is going to be... Well, actually, hold on. The resume in this case is going to be of type option t, by the way. It's not that easy. How do I do that? I think we need to do something different. Hold on. Like, I think that what we need is to have a function that is... like, I think we need to say, like, value is uninitialized. And then we say next. Next is going to basically initialize this, I think, maybe. I'm not sure yet. Like, instead of returning none, we're going to say that value is none, which means that the resumption object is now returning also nothing. And what I can do is I can just literally say that the, like, next time I generate the next, it's going to be resume. If it, like, when so yeah, the continuation object need to be convertible to the same type for that to work. So over here we will just call next and return the value. Does that work? This also needs to move the things. I'm not sure if my closures are going to be compiled properly here. Is there an example of generator to iterator in Coca? How to turn Coca effect control flow into an external iterator? You understand nothing? Feel free to ask questions. I am just making a programming language, and I'm designing right now, kind of what I want specifically. We're doing the effects, which is a weird control flow mechanism, which allows you to pause and resume the execution. It is like the coroutines, basically, but a more typed way to do that, I think. Coroutines is black magic for you. Well, the simplest example, I guess, is the code. Like, you know, like sometimes you want to write code like this, you know, for x in, like in the, so we want to have a function which does like 5 numbers, you know, print x, and the 5 is a function that just does something like this, you know, yield 1, yield 2, yield 3, yield 4, right? Is this black magic? This is pretty common stuff, I think. And the reason you want that is because this is the simpler way of writing. Right, but how does this work, right? So we execute the code before the yield 1, and then we go to executing the body of the function, then we go back here, and then we go back here, and then we go back here, and then we go back here, right? So like it's the control flow is jumping between the places. You fail to understand the implementation. There is a lot of different ways to implement the coroutines. What I'm going to go for is, I think, stackful coroutines, something similar to goroutines in the Go language. In fact, I was looking it up. I think for now I'm just going to use the Minicoro library for C since I'm transpiling to C. There's this thing. Because like it needs to, for it to be efficient, you need like platform dependent stuff, and it is done with some like literally inline assembly. There is no way to write that in C directly properly. But in short, you basically save the current execution state, which includes like the stack pointer, the and like whatever, like the value of the current registers, I guess, too, right? Which are important to preserve. And then you save those into a data structure, and then you instead have like somehow move to a different stack. So instead of having a single stack, you have multiple stacks now. The way those stacks are done can be done in a different ways, though. In C++, coroutines are stackless, but it just means that the stack is stored directly in the value. They do the conversion of the function to a state machine, which basically represents the stack anyway. That's the same as like Rust does. I think I will want eventually to have like the option to like do that too, but I will do the stackful coroutines, which is a lot easier for me to think about at this moment, at least. Which is you literally just think about it as a different, like it's no different than a multi-threaded program, right? You understand threading, you can understand the coroutines too. It's just not, it's just like implemented. It's just like cooperative multi-threading, I guess, right? Where in order for the control flow to move to a different thread, you need to explicitly say, okay, I'm going to yield the execution to a different thread, right? Which is what makes it cooperative. So it's not someone else who is controlling what thread is being executed, but the code is allowing some other code to run. Maybe. The operating system does not know when to call the coroutine. That's literally a different thing. For example, you read file in Cora, how operating system knows when the result is ready. I don't know, you're talking to maybe some specific APIs. The operating system knows when the result is ready, the same as, like, I don't know, that's just implemented in the operating system. You don't need to know how it's implemented under the hood, really, right? Do you? It might as well just be implemented in a separate thread, which is using the regular blocking APIs to read a file, and once the file is read, it's calling your callback. I think. Is this the correct implementation? I'm not sure. Anyway, we say over here, iterator is generator to iterator of ints, the do gen. Let's do the do gen over here. Let's call this gen 10. And we are generating 10 numbers, right? Right, and then we do a loop. We say iter, that's my new value. next is this, right? And we say if next is some, then we say something. Otherwise, we're going to break, so we are unwinding the loop with nothing. Over here, we say next value, print string iterator. Next is next value. Okay, print string done. Let's here to unwindable. And over here, I also want to print string done yielding, so that we can see everything. You're very bad at abstraction. You need to know the hood mechanism, personal weakness. Otherwise, you'll just put a weight code everywhere and just try it 100%. Not async code. Explain. I think I have not explained anything today, really, right? Getting good at explaining is something I want to be at. Right? But maybe I should not, like, what we want is the effects and the delimited continuations. Like, you are talking about specifics in C++. We're going to be doing it a little bit different, so maybe like maybe I should come up with a better example than generator to iterator that will allow me to explain this idea better. But like, in short, once again, what we do is we just try to execute some code, but in this code, right, we want to be able to pause this code sometimes and then store the continuation in a variable, right? So that we can call it later, so we can continue executing the code later. That's what this abstraction is allowing us to do. How exactly, I don't think it matters, because there's different ways in how it could be implemented. We could rewrite the code into the continuation passing style. We could instead do this like assembly tricks by saving these stack pointers. So the only thing that I don't like right now is that the resume and gen are the same type, but do I want the continuation to be a dedicated custom type? Maybe not, actually. Like, right now we have the this function type. This is technically always a closure, so it's a function pointer plus the context pointer, which is the captured like variables for the lambda, for example. And in this case, the continuation is basically also just a function pointer plus the context, but the context is going to be the different thing. So I think it's fine if we use the same stuff. What I am pretty sure that I have not implemented is the move lambdas, though. I think I have not implemented the move lambdas yet. Yeah. I have not. Maybe we can start with those, actually. Alright, yes. Oh, current gen end. This expects an identifier. Yeah. There's multiple things to do here, actually, to implement. So the first thing that we get complained about is this. So right now the context system only allowing me the non-generic things. And in this case, the effect is going to automatically be producing a context, it seems. Right, is what I want. We can also say instead of a current gen, right, like instead of tying this to the context system, we could literally just say, like if I want to, I can say like effect gen int dot yield instead of current gen int, we just say effect, right? Which I don't know if there is a reason for me to do that. Because this is supposed to be like a field in the context object, and also the alternative syntax for that is like context dot some field dot yield x, right? And this field is supposed to be gen int, right? Maybe if I do it in parentheses. That would work. Like I'm trying to merge the fact system into the context system and having them still as separate features, right? My original plan, by the way, was to just have the delimited continuations, not full effect, but I think we have to. Because that's a way to pass the data between the things, right? Yeah. So gen int is an effect, which is technically just a context, right? And like, do I even need to do that? We can just say that it's, well, maybe we should start with generic contexts, right? So we say that call this generator. Like, let's say that we wanted to have the generic contexts, right? That would make it a context, and context needs a type. right? So this would be generator handler key, and this is the type, which is the generator handler, right? That would be just a struct with the yield field, basically, and then we would be able to do that. Do I even need the effect? Is what I'm asking here, I guess, myself. Because this is already the existing stuff. So the effect would be just the syntax sugar to generate the handler and the context at the same time. But this is how we can already call these functions. The only problem is the generic contexts are not there yet, but we can do that, I think, easily. And so how do we do that also then, if instead of the effect, right? Because usually I introduce the context by saying like with generator int being equal to the generator to the handler, right? So we need to construct a handler as an object, right? But I think this is like very special, because over here all the fields must be functions and they have the implicit continuation objects too as the argument, right? Which also, by the way, yeah, hold on. Dot yield. No, it's fine. So yeah, maybe we just have this to introduce the effects. That syntax for declaring the effects is unnecessary. This would automatically introduce the context generator int with the value being this value. It's just that all of the functions here will have to be done in a special way, right? Sure. We can try that. Okay, let's start with doing the generic contexts then, right? So when we do the templates, we basically say that every time we instantiate it, there is going to be automatically generated for generator ints. It's going to be generator int, right? And everything like that. So where do we go? We go to minicast. We go to minicast, source, compiler, context, parse context type, right? So this is what we do, right? We say parse context type, which should give me the name of the context and the type of the context, right? But if this AST it is expected to be an identifier right now, right? Which is the what we are getting here, right? But this instead is an instantiation of the generic. So how do we do that? We can say instantiate. No, we can do parse instantiate. If it is an instantiation there, this will give me the instantiation. Instantiation is template name, template arguments, and the name of the instantiation. Okay. So we just add top level item, which would be the context in that case. And I think this is fine. Like, for example, when we want to parse instantiate into a type, we just, we say instantiation to type this thing. So we look up a type then, right? But we would want to look up the context instead. Got it. Okay. So I think what we do is, if this AST is not an identifier, but instead is an instantiation, right? How do I do that? Hold on, it's been a while. It's been a while. If AST shape is a rule like this, that's what we're doing. So we save. Yeah, and all I needed is to find the context name, by the way. Right? So we are going to... So by default, we expect this to be an identifier. Or maybe... Let's just do that, right? If it's a rule, then we do that. Let's say unwindable context name. If the rule name is instantiate, then I'm going to say that context name is... Do I use the with keyword here? I don't remember. This is cast, not minicast now. Just parse instantiate, which means that this needs to import the template to parse instantiate. This will give me the instantiation. Of the root, so I just give it the root. And then I just need from the instantiation just the name, right? And that's going to be my context name. And then we just find the context type from it. Okay. I think this could be okay. Why is unwind a keyword? Because that's the keyword. I don't know. What would you want me to change it to? It gives me it breaks out of this block with a value. In Rust, this is called break, and this over here is a lifetime, I guess, like that, with a colon. It's a return, yes, but it's a return from a block, not from a function. I guess, I mean, this could still be a return, I guess, even although we don't return from functions. A return is a good name, I guess. It's a little bit confusing though, because of how it's used in other languages. So I do a different keyword. Throw. Yes, it's very similar to throw. It's more similar to throw than to return, I guess. But they are, I mean, return and throw are very similar already. But I mean, both return and throw and break and continue, all of those things, they are all doing unwinding, which is why this is called unwind, right? Because it's a generalization of all those things. I mean, I do have a return. Actually, since this is cast, I can literally just say return. Like, I can do this. That also works, by the way. Python calls it not yield. No, yield is for the generators. Yield is the what we're doing here in my minicast example when I'm doing the generators, right? We're having a function which yields 10 numbers, which is a primitive in Python. Type direct compilation of row typed algebraic effects is frustrating because it's not the paper I was looking for, but it's more at the level I was thinking about. The runtime versus ref count stuff was not the part I liked. I may replace the GC. You're making your own language too, right, Nadia? I have not really read any papers, so whatever you are referencing, I mean, I have like heard a bunch of things, but like even the Coca language, I just basically read the docs of it. I don't dive much deeper. I don't know much knowledge about how to implement things. I'm just implementing them, following the intuition, I guess, mostly. Type directed compilation. And once again, the way I'm going to compile my effects, I'm going to use the Minikoro library in C. I'm currently transpiling to C. I mean, I'm also transpiling to JavaScript, which is I don't know if I want to maintain that or not. In JavaScript, I guess that would literally be like compiled into async await code, into promises. There are other ways. We can also do the continuation passing style rewrite. Don't know what this is. Have I been on this page before? Oh, this is the paper from the Microsoft research when they were doing, like, this is literally the paper when they were implementing the Coca language, right? Yeah, continuation passing style. Yeah, maybe I have actually been here, right? Yeah, I think one of the I was thinking about it earlier. There is if you do the continuation passing style rewrite, it has the overhead, and for it to be efficient, if the effects don't actually need to capture the continuation, which is the case in a lot of cases, you actually want to have two implementations or two like you want to compile your function twice sometimes into both the CPS style and the regular style for efficiency, especially in the presence of the functions which are polymorphic over the effect handlers. You took the front ends of IR dumps from a bunch of compilers and did the adapter, shim, etc. stuff, so they all use the same RDS and you can call each other, call gen via MLIR. Oh, you're just trying to like bridge the languages together or something, right? Boom, 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 boom. Parse instantiate name. Okay. I think I need to compile. Just build continuous. Unwind unit is not unwind string. Right. So like, since we are trying to return a string over here, this expression should return a string too, right? So if it's not a rule, I should do something. I want to do a proper diagnostic here, right? So we are expecting, when I'm parsing the context type, to either have a template or just an identifier, right? So if it's a token ident, right? Like that. Yeah, I think we can match st shape. If it's a rule, then I do that. But only if the rule name is that, right? If it's a token, then I just return the name being the identifier. And if we did not find, then we say expected context name, I guess. And the span is going to be AST span. No. Unknown context generator int. Okay. So technically I have parsed this, right? And now the instantiation of the generator with the int gave me the generator underscore int, but it cannot find it now, which is weird, because if I did the instantiate, here, right, I'm just supposed to add the top level item, which is this item, add top level item. And we add it to the unprocessed. Oh, wait, because it's unprocessed, right? I need to make sure that it's processed. How do I make sure that it's processed, though? Because it just queues it? I forgot how this works. Because we're like lazily figure out the dependencies, because we don't need to specify things in order. So we just queue, but then oh, maybe like we need to say find context type, right? This is just getting it from the context, but what we want is we actually have top level item, which has declaration and implementation, so which we also do separately. And find context type. This gives me the type, right? Top level item definition. No, top level declaration, right? We have the context. I think we need top level implementation, which is a context of a specific type. Yeah, that's what we want. So we want to get top level implementation given the name. Yes. Current compiler, get top level implementation of the context name, and it should be maybe lookup type. What is lookup type? Over here, right? The declaration is type return name. Hold on. We get top level implementation using the context name. There should be some declaration. So if it's some implementation. No, implementation is a keyword. Oh my god. Some let's just call it item maybe. If item is context type, then we just return the type, right? If it's not a type, then we say that it's not a context. Print top level kind decal. Let decal be current compiler get top level decal context name option unwrap. Since the implementation is here, we can unwrap. Then we do that. And over here we say context not found. My error reporting is very verbose, very bulky. The only like useful code here is this 3 lines. These 3 lines. Everything else is error reporting. Hello, Remarch. I'm trying to implement the compilation of effects, specifically capturing the continuations into C today. So we're going to be able to do coroutines in. I'm going to start with minicast, and then we'll see if I get into cast or not. Unknown context generator end. Yeah, because I need to process this. Wait. Oh, no. Hold on. I need to compile now, right? Find name in scope. Fine, we just say name. We're currently doing continuation stuff at work with some shitty C++ interface. It's tragic. I have not done the C++. I mean, are you doing the C++ coroutines or some like other continuation stuff? What do you use? Do you use the boost? I know that there is like a boost context. When I was researching how I would implement this, there is the boost context stuff, which allows you to implement the coroutines, right? With like call CC fibers and stuff, continuations. Is that what you do? Or something else? NIH solution from the tech lead. What does NIH stand for? Invented at home? National Institute of Health? Huh? Unable to infer the type. Value is uninitialized. Okay, value is going to be T. Not invented here. But if it is from the tech-lead, doesn't it mean that it is invented here? Because you have a custom solution? Syndrome is decision making. Oh wait, not invented here syndrome is where like if something is not invented here then it's bad, so you want to invent it here, right? That's the thing. Yeah, we are doing that with cast for sure. It's okay. I think I might have that syndrome. Is that a bad thing? Well, I mean, in fact, I'm not going to implement everything from scratch because I was literally saying that I'm going to use the mini core because I don't want to go into the assembly myself manually to implement this properly. So for now, I'm just going to use a library. At least until for now, while we are transpiling to C. It's okay, you do it too. All right, you write your own shader language, right? Because you don't like the other shading languages because you did not invent them, right? Right. Who wrote the compiler for your minicast backend? What do you mean? You did? Did you write a compiler? Did you do something? Let me keep those actually open. Did you write the C compiler? The transpiler to C, yes. That's how my Ludum Dare game was working. We compile a lot to C already. Did you miss that? The compiler from C to native? No, I did not do that. Not yet, at least. But I think we will not need that. I think we just, if we want to go native, we just skip the C and we just go minicast to assembly or minicast to LLVM directly. Whatever. All right, we expect the expression, but we got this, right? So we have the effect expression with the effect handlers. And we need to compile this somehow, right? So in minicast, I need to have a new kind of expression. The other things seem to work so far, right? Because all of that is just already existing. This is the only thing that I need to implement. So, so we have a new kind of expression in minicast. Right? Similar to unwindable, I guess. It's going to be handle effects. Handle effect. So we're going to handle a specific effect. Similar to unwindable, it has the body. Right? Why is token is a... Yeah, it's unwindable. It's... Yeah. Okay, no, that makes sense. We have unwindable and unwind next to each other. And then we have handle effect. Oh, wait, you know what I just realized? Maybe. Like why do I even need the generator handler to be the context? It's not necessarily needs to be passed from context. I think the effect handler can also be an explicit value, right? So over here, I can initialize the context manually. So I say with generator, So yeah, this is going to be the generator context, and this is just the generator. No, this is let's call this handler still, and this is the context, right? Because this can introduce the thing, and this is going to be the effect handler. I don't know, something like that maybe, which I can also store in a variable here explicitly. Is that a good idea? I'm not sure. Like to separate the features. I don't want it to be too integrated, right? It's supposed to be a separate feature. Whether we have the context system or not, the effect system. Similar to unwinding, it's supposed to be independent features. Everybody's screaming that we need to NIH the world, so we don't have the POTUS listening to our BK's phone calls. Investing with our judges' banks accounts. Most urgent is NIHing the hardware because there are big fat backdoors and all that stuff. The government here and in France is moving to Linux because of similar concerns. Bum, 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 bum. Because Bundeskanzler? What does that even mean? A Chancellor of Germany. Yeah, it's like your president. You just call it the Chancellor, right? For whatever reason. I don't know the difference. I'm stupid. Yeah, I think this kind of makes sense. Do I want a special? So like we have a special resume. But I think similar to the unwindable, right? Like we have unwindable, and basically, like a loop in this case is the handler of the unwind, right? And we can when we unwind, we explicitly say where to go, right? So similar to that, the effect handler could be named. So I can say generator int. I mean, we can, I don't know, what should the syntax be? We can say handler generator int is equal to that, for example, because we specified the type of it and the value. And then we just put it into the context. By the way, in case anyone is wondering, we're doing the minicast here. I don't really worry about the verbosity here. The syntax sugar is supposed to come in cast. If we need to. Which is also why maybe I don't like the resume being the keyword. I like somehow also name it here, the continuation. You know, like when you are handling the continuation, you know, camel, for example, you say effect, I don't know, effect yield and comma k. We just literally say comma, and this k is the continuation now. Also, if we follow the OCaml example, OCaml doesn't have like the fields here, by the way. Instead of these fields, the effect accepts like any type, and with the ADTs we can choose which one we're storing. But that just means that I could use multiple handlers, I guess. Yeah, never mind. Like, we can simplify this if all we have always is a single operation, right? Like the generator only has the yield, right? So what if I just am able to handle the single thing, right? But the reason we want this to be multiple operations is even although I could do like multiple different effects for multiple operations, that would be compiled to multiple separate coroutines, I guess. And yeah, the continuation is delimited differently a little bit. So we don't want that, I guess. So how does this work exactly? Like, this is a little too complicated, maybe. Can I simplify this further? This over here is easy. We just need to have the handler somehow being initialized. So like that is what I'm trying to figure out here. Like, should the, like, sometimes we only have one effect. In this case, maybe we can have just that, right? Potentially. So we have a single like closure basically here. It's a closure which is also a little weird. Yeah, it's a weird closure, which is going to be compiled separate, differently. And by the way, can I... If it's a closure, do I need something like the move keyword here too? Potentially. What if I capture another value which I use in the handler? Does it matter? It probably does not matter though, because for the effects, actually, you're only like the lifetime of the handler is supposed to be the lifetime of this expression, basically. So the things that I'm capturing are always alive, and we don't need to move anything. We don't need to extend the lifetime of anything, right? Yeah. But since I want to support multiple operations, like basically the syntax here is going to be with effect handler, then we specify the type, which is what we're going to be constructing. And this type must be a struct with every field being a function, right? That's the rule here. It's just a little bit too complicated, is it not? Can we... I don't know if I can simplify this further, though. Bum, 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 bum. Can you fully simplify that, but combining it with the other thing? What thing? Just messing? Okay. Well, I mean, I think this is fine. I know that in Coca they have like the like with the syntax sugar in cast, right? Like what we want is basically with like, I don't know, we'll like handle the yield, I don't know, x int, and this is just going to be the body of this or something. And then we just do the body like that, I guess. Like this, but this is basically the syntax sugar for that more verbose syntax. Maybe this is fine. So let me change the syntax. Boom, 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 boom. Handle effect, right? So we say with effect, then we have the name. So this is handler name, right? Then we say colon colon. Then we say handler type, right? And then we say equal, and then we say handler value, and then we do the body. Right? There we go. This parses. So this over here is going to be the handler name. This is the handler type. This is the handler value, but the handler value needs to be a specific one. It must be a record, a struct with fields where every field is a function, which we compile in a special way. Right? Let's see. So when I handle the effect, we have body, which is expression. We have the handler name, which is a string, right? Handler type is just a type, right? And handler value is just going to be, it's not an expression. It's not an expression. We want specifically the fields there. Actually, hold on. Like, let me first think about how do I compile this. Let's say that we have multiple operations in my effect handler, right? We have yield, and then we have like something else, right? How do we compile this, right? So when we perform the effect, I need to capture the continuation and then do some code, right? No. This is, yeah. Because they have different return types. Even although I can model the arguments with a single thing, the return type would be weird. Yeah, I think we keep multiple different operations possible. So handler functions, I guess, right, is going to be a set. Do I do a set? Array list of fields. It's kind of similar to that. Maybe we do a list of a handler, a fact handler function, and we have a fact handler function is having the name. And what do I represent it as? How do I construct a lambda? Function definition. Do I just do function definition? I mean, there is no capture mode. Captures. When I compile it, do I create a separate function actually in my C code? Maybe what we should start with actually is just writing the C code manually for this. Yeah, how about that? How about that? And also, can we have this mini Cora library? I know that it is... Actually, I'm just going to have this as my sub-module, I think. We're just going to have like mini Cora as a sub-module, and... do I want it to be part of the dependencies? Sure. It's called deps mini Cora. Right? So this is just a header only. Stack full cross-platform coroutine library in pure C. Bum 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 bum. I don't know how difficult would it be. Define minicore impl. The following simple example illustrates how to use the library. Why don't you define minicore impl? There is no else. If you don't define it, then it's just going to be an empty thing. Got it. GCC temp test temp test C. Right, so if I define this, then it's compiled temp test right? So we have coroutine 1, coroutine 2, whatever this example is doing, right? First, initialize the descriptor object through mco-desk init. Configure the desk fields when needed. Customize user data or allocation functions. Call mco-create with the output coroutine pointer and a desk pointer. Is this like the global one? mco descriptor. I don't know, what is a desk? Structure used to initialize a coroutine, so it's not a coroutine yet, right? I can have a single one for all the coroutines. So we create the coroutine. Coroutine was created. The status of the coroutine is suspended. If impl is not defined, the include is a header file. Oh, I see. That's how they do it with the header only library. It's technically a header plus C in a single file, right? It's a header plus implementation is a single file. So you're supposed to define the Minicore impl only in a single C file, right? Got it. We create the coroutine. It starts in a suspended state. Then we need to resume it. Core entry. Oh wait, no, we do initialize the descriptor over here. Too. So this descriptor is specifically about this coroutine. So why do I need to go through the descriptor in it and then create it? Because I might want to create a lot of coroutines with this from this function. So this would technically be like, it needs to be done once for every function still, maybe, right? Or maybe not. I'd expect effects to be implemented with set jump, long jump rather than coroutines. When I tried the set jump and long jump, you can only jump up the stack, so you lose the stack when you do the long jump. But what we want for coroutines is literally to preserve the stack, so we want to swap to a different stack. Which is not possible with set jump, long jump. Instead, there are implementations, and this library is also doing this with different things. There is uContext, which is which is deprecated, as I understand it. There is the fibers in the Windows API and in the Imscripton, it seems. Or you can do it with like inline assembly. Set jump, long jump don't let you switch the stacks. No, I'm pretty sure it's not. No. That's not how, and that's not how Minicore works. I mean, we can take a look if there is a set jump. There is no set jumps here. No. I'm like, when I tried it before, I was also assuming that that's the case, but that's not. Long jump is just jumping up the stack. So it's, and like I don't use this for unwinding either because it literally just discards the stack. But we want to also clean up while going up. Long jump just restores the stack environment, but it does not save the current stack. Well, I mean, I guess if you use like you need to make sure that you are in a new stack when you create the continuation. Maybe then you would be able to use the long jump, right? Like when, like you need to set jump and then you need to create a new stack, because otherwise that stack that is like continuing after the set jump is going to be discarded completely. Right? Like there must be multiple stacks anyway. You mix up Minicore with Odin coroutines, which is a different library. Do they implement it in Odin with set jump, long jump? I don't know, Minicore is used to make some language, the Nilua language. Which is like a statically typed Lua or something. But yeah. It's the uContext that allows you to do that. Those are the C libraries. You have the what is it? Swap context function, right? And this is the thing that is allowing you to save the stack and allocate a new stack yourself and do this. But this stuff is deprecated, and it's only on Unix available. So it's not cross-platform. Currents are probably fine for effects. I think you only need one of them. One of what? I mean, coroutines is like the effects are literally the coroutines. I mean, it depends on the definition of the coroutine, I guess. But I mean, yeah, we need to capture the continuation, which is the coroutines. I need one coroutine. No, we can have nested handlers. So we can have nested coroutines too. Minicore supports that as far as I understand, but we should test. Okay, so we create the coroutine with 4 lines. It starts in suspended. Resume to start for the first time, switch into its context, right? So when I create this automatically, right, this is what allocates a new stack, basically, right? mco create. Yeah, there is the allocator. So we allocate the coroutine. And we allocate a specific stack size here, right? Which is not what I want in my final implementation, because I think eventually what I want is a growable stacks. Not a fixed stack size. But we can do that later. With a custom implementation of this. With segmented stacks or copied stacks or whatever is currently used in Go. I'm not sure why segmented stacks don't work. I mean, I know why they switched from it in Go, but I think it can be the thing still. But we can start with like the fixed stack size for every coroutine. That's okay. So we create it, resume. We get back from coroutine context in suspended states because it's unfinished, right? Yeah. So we resume it, and we go, and we continue being here after we yield, right? So we suspend, and then we resume it again, and then it's going to be finished now. And then we can destroy it. Okay. That seems easy. I just don't understand why we create it in 4 steps instead of in 1 step. What is a descriptor? You can also... Oh, yeah. You can do the custom stack size when you create the descriptor. Not when you create the coroutine itself. Wait, hold on. You have MCO result. So you have the coroutine, the result, and the descriptor. Can returning effects be function calls? Yes. But like I am going, at least for now, like my idea was that we literally have the returning effects to be not using the effects at all. Like it's not an optimization, but it's going to be explicit instead. But it can be an optimization too, right? Like if I want the returning effects, which you mean like the effects which are doing a tail resumption, which are resuming the continuation in the end of the handler, right? Those can be instead not even capture the continuation, but just be compiled down to regular function calls. Yes. But if we want to do that, which actually makes me think that like you see over here, right? We say resume here, so we actually need the resume. Maybe I want it to be specified over here in the signature also. Yeah, it's like implicit callback arguments. Yeah, that's why I'm having these separate, right? The effect handler is going to be named, but the implicit system is the context, right? So if I want the effect handler to be implicit, then we use the implicit context system, which is separate from the effect. And in the implicit context, you can put anything. You can put the regular functions there, right? You can put the regular whatever, any value there. But yes, you do have a point, which is when I'm initializing this, maybe like for some of these, I don't even need to capture the continuation, and I want this to be even more explicit, right? If this is a tail resumptive thing, so we just do it. I resume here, like that, immediately. Then I think instead we can... I think instead in this case, it should just be literally a regular function. So maybe there should be a separate syntax for the ones which is capturing the continuation, is what I'm saying. Right? So if this is the thing that is capturing the continuation, it's libc, I think, more than Unix. It says systemv like, but it's not working on Windows there, the ucontext, if that's what you're talking about. Yeah, and there's like some var arg stuff. This over here, which basically like limits what you can do there, I think, or you need to like, I don't know, it makes it weird. As far as I understand this stuff, which is why it is deprecated or something. I don't know. And if I want to capture the continuation, I can also give it a name then. Capture continuation into resume. And then we just say resume here. Is that good? So in this case, it would be explicit, this optimization. We don't rely on the optimizer anymore. We are being explicit about it. whether the continuation needs to be captured or not. Yeah, because otherwise it's literally just going to be a regular function and I don't even need anything. We compile it as is. It's not special anymore. But the capture continuation is a specific, is a dedicated one. Or hold on, can I make this to be part of the closure? Can I have any closure? No, because like what is the continuation that we're capturing, right? It is the continuation. Oh, wait a second, hold on, maybe this is how I can decouple it further, right? Because we have the handler. And by the way, this is not the correct type because I need the yeah, maybe we actually have the delimited continuation as a built-in block, right? Because I need to capture the continuation of the I don't know, of the delimited continuation, you know. This is this becomes a little weird. Let's see. So let's say that we have a delimited continuation boundary, right? Which I think is called usually shift or something. I'm not sure. It's shift reset. So we say delimited continuation. We give it a name, similar to how we give a name to the unwindable block, right? We say delimited continuation delim, and then inside of this block, we would be able to inside of this block, I would be able to capture continuation of the, so continuation after this delimiter, right? We capture this continuation into the variable called resume. Or do I just say we capture continuation? No. Yeah, it should be like part of the function signature, I think. Yeah, I think it's part of the function signature. So we can like literally create a function f, right? Which is a function like this. And we can store it in a variable where we will just capture the continuation up until the delimiter into the resume. And this is going to be the function which would say that gen is resume, and then we don't need this special syntax for the handler, for the effect, right? And we actually have the delimited continuation as the primitive and not the effect handlers then. Right, so whenever we capture the continuation, we must create a function, right? Can I capture the continuation without creating a function? Like the delimited continuation, the basic building blocks in other languages is basically, it's the shift reset. I have not reset like shift reset. There is also prompt control. Hold on. Prompt control, shift reset. I never like really read about those much. shift reset and all that. There is a whole zoo of delimited control operations, and it does not seem to be a bounded set. Google implement support for them in a separate module. Scheme lore. Yeah, that's what I was going to do, the scheme. Like, because scheme is the main language that implements that. Control features. Continuations and prompts, right? So we can do the call CC, but that's capturing the entire continuation until the end of the program, which is too much. Wait, hold on. Call CC never has to, nor actually does, capture the whole current continuation, but only at the end segment. Blah, 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 blah. Composable and not composable continuation. When a continuation captured with call with captured continuation is later invoked, the invocation never returns to this call's continuation. In the sense, such a continuation procedure is far from being a function in the mathematical sense. Continuation marks, threads, fluids. That's too much text. Shift reset. This library experts. Oh, shift reset is also like a library, right? So there's a more basic building block, which is what they implement shift reset using, right? So what does shift reset do exactly? So reset at expression body. We evaluate the expression to obtain a continuation prompt tag. A continuation prompt is defined by this tag, is installed with the default handler in the current continuation, and the body is evaluated within this extended continuation. What? Is there like a short summary of this? We can look the legitimate continuations on the wiki, right? So here's the example. We have shift reset. That is not like what I was just seeing here, right? Oh, wait. It's, oh, wait. It's because of shift at reset at, right? But there is the regular shift reset. Denvy and Filinsky operators. Reset value is value, but reset with the shift inside is whatever. Your scheming was mostly in the 90s. I never did scheme. I just know that it's known for these abstractions. But I never used it. There's prompt reset, and there is the prompt control shift reset. Prompt control. Higher order control. Prompt val is val, which is very similar to shift, right? Shift reset is actually, yeah, shift reset is later here. So what's the difference? Control K export, like we are comparing this to that. Reset EV. Oh, it's this over here. Num decay expression. EV versus a reset EV. Is it because I can basically have a I can still use the same continuation after resuming or not? Is that the difference? Hello, Bad Cop. Even when you were using it actively, it was never a scheme wizard sorceress. Yeah. All right. But does this make sense? I was just trying to figure out what is this closest to. We have the delimited continuation, right? So this gives me a tag, right? That's what they call that, right? They have a tag. The tag expression, right? I just always have a tag. Unlike them, which have like so if you used without a tag, that it's like a global tag or something, I suppose, right? But we always want to name it, so this is the tag of the continuation, and then when we capture the continuation, this is the yeah, over here I'm creating a function. But what they do is we just like capture continuation, which is like the reset or whatever, probably. Continuation delim, right? So this is like reset at, right? Which gets from stack identifier, from tag expression, identifier, and expression. No, we just want a reset at. Wait, what? It's reset shift. Yeah, this identifier is the continuation, right? Yeah. So this is the expression, which is the tag of the delimited continuation. This is the identifier, which is the continuation, and then, yeah, maybe we just do that. So it's not part of the function signature, actually. Oh, yes. I think that makes sense, actually. So we capture the continuation delimiter. This is the continuation. And then over here we have the expression that we want to calculate. That makes it a lot simpler, right? And then, so then, what would I write here, you know? For the actual code that I wanted to write, we say delimited continuation. Let's still call it delim, sure. So this is what we, yeah. So we have the delimited continuation. We initialize this, right? Then this is what we want to calculate. So yeah, we want to calculate that. But we are going to initialize the handler, and the handler is then going to be, so this is just a struct with the yield. So this is the already available syntax for us. This is just going to be a function x int. So this is going to be a regular closure, right? But inside of this closure, when we call this, this is when we are going to capture the continuation from the delim, which means that this must be alive when we do that. But that's yeah, and we get the continuation into the resume, and then we calculate the thing. So we store the resumption in a variable called gen, and then we just return some int x. Okay, I think this is okay. So this brings me back to my original idea, where the algebraic effects is not the primitive, but it's the delimited continuation which is the primitive. Like, right? And in this case, it is also very explicit. And if we want the handler to be like tail resumptive, it's not an optimization. We just don't capture the continuation, right? And that's going to be converted into a regular function. Right? Do I like this? I think this is actually simplified. So we don't like, because the algebraic effect is just a combination of multiple features. It's a combination of the feature called functions, the feature called delimited continuation, and the feature called the context for implicit for passing it around implicitly. Plus, for it to be safe, once again, the delimiter must still be alive here when we capture the continuation, which requires the borrow checker, but yeah, we don't worry about safety yet. I think I like this. Continuations are more general, so the specializations are in some way performance optimizations by specialization. Can you give an example? Well, I mean, no, continuations are more general than the algebraic effects. I think it's not true, because you can do any like algebraic effects is a specialized way of doing the continuations, right? Because it's like giving more structure to it, but it's basically a syntax sugar is what I'm saying. But yeah, continuations are more general, but I don't see how I would compile it better if I have the dedicated algebraic effects. Like, once again, the one of the optimizations that I can see is when the algebraic effect handler is doing a tail resumption, in which case we don't need to capture the continuation and we can compile it down to a regular function call. But in this case, since the continuations is what we're using, we can literally just get rid of creating the delimited continuation and of capturing the continuation. I would literally just do that, right? And it is explicit optimization now instead of being an implicit one. Which I think is a good thing, no? All right, do I want to change this into a different keyword though? We can start with that. I have changed the syntax like 3 times already today. But I think I think this is the final form, unless I can see a problem with it. Can you give me an example, if you can? Do you think that this is too general, which would prevent some optimizations somehow? Continuation. Yeah, so basically, I have this effect, right? Effect. We get rid of this. Handle effect is not needed anymore. And creating the effect is not needed. We just use regular struct and contexts. So what instead we do, and we don't have the continuation, the syntax is also unnecessary. We instead do similar to unwindable and unwind, literally, which is instead doing the continuation stuff. So the like limited continuation and and capture continuation. Let's just call it that. But maybe we can have a dedicated words for that. Maybe it's shift reset, maybe it's control prompt or whatever. But we have a delimited continuation, which just gives me the token and the body, right? Just like unwindable. Yeah. So this is where we create the coroutine basically. And capture continuation is when we yield from the coroutine. Yeah. So we capture continuation. One other thing though about the syntax is for it to be less right, because this resume is supposed to be an identifier, but this can be any expression. So technically like the absence of the keyword here is a little bit capture continuation, I don't know, like into resume or something. I don't know, maybe it's okay. Think about it when we try using it. So we capture continuation. This is going to be the so the token, just like unwind. Sure, let's do that. Similarly to unwind, actually. Type dispatches are where the overhead is often hidden. Type dispatches. Can you elaborate? So maybe let me. So we're just going to have a regular closure here, which is just a function, right? And when we capture the continuation, this is going to basically swap the stack and store it in the resume, the current stack of this continuation. And I'm going to use the mini core library for that. Other than that, it's just like any other function. What is the type dispatch? Like, I'm not going to dispatch any types anywhere, right? The type of the token here, like the only thing that I need to care about here is the type of the result of the continuation, right? Because this is an expression, and this expression should be evaluated to, in this case to nothing, right? But like when we have the the result of the expression is part of the type of the token, of the tag of the continuation, which is what I already do for unwinding. So it is similar. So we know the type of the resumption, right? Yeah, but the type of the resumption is basically now. Wait, hold on. What's the type of the resumption, right? Because the resume should return the type of this entire expression. But what's the argument to this? What's the argument of the resume, right? That's the question. But the argument of the resume, I guess, I think I need to specify it here. Yeah, so we don't have just the continuation because we need to pass some data there. In this case, I don't want any data. But in the general case, Wait, hold on a second. I'm confused now. Do I need the extra arguments here or do I not? Like, is the type of the resume maybe just this into the R, and the R is like the type of this continuation, right? So this is of type R, this entire expression. Do I need the arguments here? That's the question. I mean, technically, I can pass the arguments using the values here. But that, yeah, and that is where we want the optimization, I think, right? Because, like if I want to if I will construct a new function, and that would store. Actually, no. Wait, hold on. No. Yeah, well, because we just resume, and we. Or no. Yes, hold on. We capture the wait, what? I'm confused again. What am I doing here? We are capturing the continuation into the resume. And we instead do this code. I'm confused again. What have I written? Capture continuation token space continuation identifier and value, right? Fine, let's try that. I did once again. I always like type delimited continuation with an E instead of an I. For some reason. Okay, there we go. The syntax is parsing. There's potential for misremembering the material of the precise scope of what I actually went over in my learning. Well, I mean, there's probably a reason, right? Like, why is everyone doing the effects as the primitive? And I am somehow doing it differently here, right? But maybe I'm onto something. But maybe I'm missing something. Capture continuation into the resume. So what's the continuation here? We have the code after this, right? And the code after this is not going to be invoked. But what is the what is the type of this expression? The type of this expression. Oh, yeah. Hold on. The type of this expression is the argument to the resume, right? Yes. Because when I call the resume, we continue invoking this code, like after this. Like in this case, since this is a statement, the argument to resume becomes unit. The return type of the continuation is the where we delimit the continuation, so the type of this expression, but the argument is what we store here, right? Yeah. Not many people do effects at all. Yeah, I'm saying that there is like a lot of research going into the effects currently. I think there is a lot of languages that are trying to do that, and all of them are doing the effects as the primitive, as far as I understand. I mean, I have not, maybe I can't say that I have looked at all the languages, right? But from what I have seen, that's what people do. So let's say that I want over here to say like let like args, and I will want to have multiple arguments here, right? Yeah, that's what I want. I want to have like multiple arguments, because multiple arguments could be optimized away, right? Like think about the function that takes a single argument, which is a struct, which is all the arguments, which is what we can do, right? Or instead of function, which takes arguments as separate. I think, like, it is actually, if you do it in a language like Rust, for example, can it be that the single argument, which is a struct, is going to be still passed around in registers and stuff? Because when you say a struct, which is the arguments, isn't it forcing this specific memory layout and stuff? You think it's just ergonomics? You can just implement effects as part of the stdlib with continuations if you want? Yeah, that's the plan, right? We're just going to have the syntax sugar, which is going to do the effect, but the low-level primitive is the delimited continuation. There's 3 low-level primitives once again, right? It's the context system, the delimited continuation, and the regular functions, the closures, I guess, plus the borrow checker for safety. Yeah, I guess like one of the things, by the way, yeah, maybe it's because of the safety, by the way, right? Because like right now, I am technically would allow to store this delimited continuation token in a struct, and I could capture the continuation from outside of the delimited continuation boundary, which would result in like undefined behavior. And usually in the languages with the effect systems, you are not allowed to access the effect handler as it's not like a first-class value, and that is done for safety because it's not supposed to be able to escape the function, usually. Right? But I mean, it could be just done with escape analysis, too. Instead. But I'm planning to just do a full lifetime system. So when I say let args, let's say that the argument is going to be like A, right? Then the resume is going to be function from A into R, right? Where R is the type of this expression. Let result R is this, right? So this is the R, and this is the A, and that's what the resume becomes. So what if I want multiple here? Does it mean that I need to support? So the captured continuation is potentially returning multiple values so that I don't need to generate a struct for multiple arguments. Right? Like if I want to have A and B, how would I do that? I don't have destructuring, and I mean, yeah, we want. I mean, I can just say let A, and B to be like that. I can have the this to be a special syntax. I suppose. It means that not this is an expression, but this entire thing is a dedicated syntax. So these values become the arguments of the resume then. And then we can use them after we continue. And if we skip the let, then it's just same as having no arguments then. Right? But I think we start with that one anyway. Yeah. Does that make sense? I think this makes sense. Couldn't find a template named generator. So wait, current generator context dot yield. Sure. R is not found. Yeah, like this is just for example. We don't care. All right, so we actually have the expression which is delimited continuation and captured continuation instead of handling effects. Okay. Delimited continuation. Right, so this just has the token string body expression. Token type wrapper. I think it should be similar to unwindable. I think this is internal thing. Don't worry about it. And capture continuation is going to be token, which is expression, which needs to be the type of the delimited continuation token. And then we have the continuation, which is a token, a variable name. And what do we call this? Is this the body? What do I call this? This is what we swap the current continuation with. So like, do I call it the body? What do they call it here? Just expression, maybe? I don't think it's body. But sure, let's call it body for now. So we also have a new kind of a type. So similar to unwind token, we are going to have the delimited continuation token, which has the result type. So the only thing that I care about is the result type of the thing. C or C++ for Raylib? You're writing in Raylib? I don't know. Minicast. That's what I was doing with Raylib. I guess I would still choose C++, but I would maybe not use a lot of C++ features. But having the templates is very nice sometimes, instead of copy-pasting code, I guess, right? Or doing some macro magic, which is why Minicast has the templates also. But otherwise, it is very, like, we don't have classes or whatever. Yeah, I don't know. I mean, I wouldn't just, like, there are other languages that you can consider, right? I think instead of C and C++, you can always choose, I don't know, Zig, Odin, or something like that if you enjoy those, or yeah, I don't know. I would just not use Rayleigh, but something else maybe. But what is it? That's something else. Rust and macroquad instead. In GUIL scheme, they implement exception handlers in terms of the limit continuations. I think no. I think I do the exceptions differently. The delimited continuations is a thing which is going to be specifically linear continuations here. Same as like camel. The continuations must be linear because you need to clean up after yourself sometimes, right? And the unwind, that's why I have basically the two primitives, which is unwinding versus the continuations. Unwinding is what does the cleanup, and delimited continuation still saves the old stack, which if we want to clean that up. So if I don't want to use the continuation, then I would still continue with and unwind that. You know what I mean? In general, though, there are also some languages that allow you to even call the continuation multiple times, which allows for multiple futures, like for, what do they call it, the non-deterministic stuff or something. I don't think I want to support that. That sounds I mean, it sounds interesting, but yeah, I think I want specifically the linear continuations where you must use the resumption object always, and if you don't use it, then that is the unwinding primitive, which is different, which is basically the exceptions, I guess. In GUIL, they implement exceptions using the continuations, but well, I mean, it's possible to do that if you collect the garbage, but I don't know. I feel like I want them to be different because, like, it specifically is doing very different things, right? In one case, you switch the stacks, and in one case, you go up the stack. It is different. Well, I mean, I guess we could, like once we have the proper IE, right? So the resumption object would have the destructor. If you don't use it, it would automatically actually resume the continuation by throwing an exception, which is the canceling exception or something, right? Which is just, but yeah. Yeah, that's it, basically. Which is exactly what I do already in my OCaml code base. Because if you don't do that, then then by using the effects in OCaml, you're going to leak memory if you don't actually continue. So I have a dedicated exception, which is the cancellation for that. Maybe in GUIL they just call Do they like because one of the other names of the algebraic effects is the basically resumable exceptions, right? But when I think about exceptions, it's the ones that are only going up the stack and don't allow you to resume. Because then, like, you don't need to capture the continuation at all, right? Can you resume after handling the exception? There is continuable, yes. I think because I see the continuable here, it basically means that the exceptions are the effect system in GUIL, is what this is meaning. If the continuable is true, the handler is invoked in tail position relative to the raise exception call. Otherwise, if the handler is returned, no continuable exception. Yeah, they have continuable exceptions. Which is the effects. So they unwind to the prompt tag, but they resume back, which means that they don't unwind. Actually, yes. You only unwind if it's not continuable, because otherwise you just lose the data, which is required for continuing, right? Yeah. Effect, as we don't have effect handler function. What was I going to do? I was going to add the type. Unwind token. We have the limit continuation token, which is just result type. Yeah. I mean, I think that's all. The unwind to prompt tag. Yeah. Okay, so I mean, I have not implemented that yet, right? So we need to have a new exception, a new expression over here. 2 new expressions. Let's see. We need to delimited continuation. Bars delimited continuation. And we need capture continuation. Similar to unwindable. It's going to be similar to that. Let me copy. Parse delimited continuation, right? So we have the expected type, which is going to default to unit. Sure. We have we just have token and body similar to unwindable. We need to instantiate the type then now to delimited continuation token. And we have the delimited continuation token like that. So this instantiation is for the implementation details of how I store the token. We'll get to that. We have the variable token type, parse expression body, and it is expression delimited continuation. We have token. So this is very similar to unwindable, literally. And then we need to parse capture continuation. That is going to be 3 children. We need token. We need token. Continuation identifier and body. Token AST continuation identifier body. Token is an expression. The token type should be... Oh, it should be a reference. Should it be a reference to the token? I guess. Sure, it should be a reference to delimited continuation token. And this is how we know the result type. Parse expression. Expect a reference to delimited continuation token. Got this. So then we have body. Oh, we also say continuation identifier is expect identifier. This must be an identifier. Then we say body. We are parsing the body. What should be the result type of this, by the way, right? Also, what is the result type of this thing? So we're swapping the current continuation with this, right? So this is the new result of this expression, right? Yeah, so it is still the same result. The result type is the type of the body. Yeah. And shape is going to be capture continuation. We have token, we have body, and we have continuation identifier. The type is expected type on rep or unit. No, this the expected type for now, let's say that it must be a unit. Right? If this is... Yeah, I think this must be a unit. But also now, when we are parsing the expression of the body, we should... Let's just recompile here. First. Parsed expression. Wait, what's the issue? Token, continuation. Oh, we have capture continuation. It says just continuation, not continuation identifier. Maybe I should call this also just continuation. And in the syntax too, we just call this continuation. Okay, so I have just implemented compilation of that into the intermediate representation, which we need then to transpile to C, but we need to specify the representation of the delimited continuation token. So we have the unwind token already. This is the runtime of a minicast. So in C, I represent the unwind token as basically an integer, and we are going to have the but if we are using the mini core library, then I guess the delimited continuation token contains the reference to the coroutine, right? Because when we are going to capture the continuation, I probably need to like figure out the proper example still, right? So we have the coroutine, right? We can yield, and that gives me the coroutine as a value. Hold on, but we have like this code also. Let me think. So when we create the delimited continuation, we create the coroutine, right? And the body of the coroutine is just the body of the delimited continuation expression, which means that I need to convert that body into a separate function, which is annoying because I need to capture the things for it to work, right? Can I create the coroutine? Yeah, I mean, yeah, it takes the function pointer. And the description, when we can do the user data too, which is how we pass the captured environment to the coroutine. Okay. So we create the coroutine. Then when we do capture the continuation, I'm going to yield, right? So we do the mco resume, and we have two things. It's either a suspended going to be after that, or dead, right? Dead means that we did not capture the continuation inside, so we just return the result of me calling this function. If this function was not void, but it was returning something, how would I? It would be somewhere inside of the Cora. I don't know. Maybe I store it inside of the user data structure, not on like, yeah. Instead of returning, we just assign it to a value, right? And then we get it. But if we did suspend, then what do I do? Because if I did suspend, then I need to run this code over here, right? So this code over here is also a different function. Is this also supposed to be like a new coroutine? So this code would be compiled into two coroutines. This is one coroutine and this is the other coroutine, right? And then we can like switch between them in the yeah. We can switch between them. And this is just the executor basically of the coroutines, which is just doing the continuous polling, right? It's just that if one of them is suspended, then we need to switch to a different one, right? And the one that we switch to should be like saved somewhere. Baby, you hear the baby? Yeah, there's baby screaming at mom. Like, if I look at the C code though, right? Technically I could do what? Like this code is not necessarily needs to live in a different coroutine. Maybe this is just a function that I would call. But but I need it to be in a coroutine in case I need to capture the continuation, like because we can have nested capturing of the continuations, right? I can capture it again here into resume too, and this is also supposed to work, right? Because we might want to call like the same effect from within the effect handler, right? And for that to work, we must do that. But I can see a potential for optimization for not creating a new coroutine, I suppose. Right? And I guess this is the difference between shift reset and prompt control. Literally. Do we allow capturing the continuation here or not? Right? Where was it? I have too many tabs open, and to close them, I cannot handle this. Does this talk about prompt control? There's a prompt construct, prompt control, shift reset. There's also cap2 and F control. I don't know what that is. Well, I mean, I need to figure out the prompt control and shift reset first, the proper semantics. Too much text. I'm too lazy. But I think that's the difference. Whether you are allowed to do another shift inside of a shift or not, right? So maybe because of that, we also want to have two separate primitives, actually. In that case, I should probably just call them, just like they call it here. Various operators have been proposed. Independent is continuation passing style, which is not based on continuation frames. Shift reset gives rise to static rather than to dynamic delimited continuations. Reset operator sets the limit for the continuation, while the shift operator captures and reifies the current continuation up to the innermost enclosing reset, right? Like, I mean, yeah, I should probably call them shift reset instead of capture and stuff, right? I don't know, for some reason I find this naming weird. Why are these things called shift and reset? Why shift reset is called shift reset in scheme? Why? Who do I ask? Does this guy know? Because it shifts control from normal execution into your handler function. Because after the continuation is captured, reset provides the delimiter. I don't know. Pum, 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 pum. But I think for the more general cases, when we want to be able to capture the continuation here, too. But the other question is, I still need like why is the shift reset and prompt control having different keyword for defining the limits, right? Because it could be a shift reset versus control reset, I guess, or something. Oh wait, hold on. We also I see another implementation potential, I suppose. We don't need to create the coroutine until we need to capture the continuation, right? Maybe this is when, yeah, maybe this is when we capture the continuation. This is when. No. In order to capture the continuation, the resumption object is the object. So this is the coroutine for sure. Whether this needs to be the coroutine though is a question, right? Dun, 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 dun. All right. Anyway, so what we're going to have is an mcoro, I think. Where is my runtime? Right. I need to have delimited continuation token as a struct, which has the coroutine. So this is the current coroutine that I am executing, right? So this is the current coroutine, right? Which is an mcoro. It's a pointer, mco create. I see. What is the descriptor, by the way? I still don't understand the descriptor. Is there a documentation for Minicorum? Boom, 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 boom. Coroutine represents an independent green thread of execution. Unlike threads and multi-threaded, a coroutine only suspends execution by explicitly calling a yield function. You create a coroutine by calling mco create. The sole argument is an mco descriptor structure, which is a description for the coroutine. The mco create function only creates a new coroutine and returns a handle to it. It does not start the coroutine. You execute a coroutine by calling mco resume. When calling the resume function, starts its execution by calling the function of the coroutine starts running. It runs it until terminates or yields. Coroutine yields by calling the yield. When a coroutine yield, the corresponding resume returns immediately, even if the yield happens inside of a nested function call. The next time you resume the same coroutine, it continues the execution. To associate the persistent value with the coroutine, you can optionally set user data and later retrieve with mco get user data. Okay. But why is the user data part of the descriptor and not part of the mco create? Because, like, I don't know. I don't get it. Mco descriptor in it. So the descriptor of the coroutine has the stack size and so it's just a function which takes the coroutine as the argument. I see. And the descriptor. Configure desk fields when needed. What does the descriptor init even do? Sets it to 0. Stack size should be aligned to 16 bytes. What is storage? Storage is different from stacks. Coroutine storage size to be used with the storage APIs. Oh, it's the storage API? I think it's for actually... Yeah, I think the storage API in this library is for, yeah, for mco push and pop. So we have like a stack to pass the values between the yield and resume. Yes, literally. Yeah, so that's the data. And what's the user data then used for? Get user data. Anyway, the synchronization token just needs the core, right? So like this. So this is defined there. I might need some other data here, but maybe that's all that I need. Tuple doesn't have a field. Tuple doesn't have field body. Because it's capture continuation value, it should be body. Resume not found in current scope. Yes. So yeah, so now the resume, it says that this is not found in the current scope because I have not done that here. When I'm parsing the capture continuation, we have the continuation object, and this should be added to the current scope. I need to create a new scope. Over here, we create a new scope, and we add a variable named continuation, and the type of it, let's say continuation type. What is the continuation type? Continuation type is going to be a function, and I'm going to say a function type. Call convention is going to be none. We are going to have 0 arguments. Call convention, non-arguments is an empty list. Result. So this is going to be a to-do, right? Maybe. But for now, we start with empty arguments. And the result is going to be literally this result type. Yeah. So now we know the type of it. It should like so we should at least type check here. If I recompile. We don't type check. We expect to type unit got option int. Oh, right. What's the result type of this? Body, right? The result type of this should be also... Wait, it should also be the result type, right? Oh, yes, but the result type here is not that. It should be value. Yeah. Yeah. I guess we can just do this over here. Value is this. So value is actually going to be optional t, right? That's my next. Which, I mean, don't I just implement it directly here? Because that's what I return. Delimited continuation. Wait, this is weird. Something is wrong here. Something is wrong here. I'm creating a new continuation every time I'm calling the next on the iterator, which is wrong, I think. Or is it not wrong? Feels wrong. Which means that I create a new coroutine on every next, but that's not what's supposed to happen here. Expect to type unit into unit, but got unit into option int. Yes. Okay. And that is literally why I was doing that. Because I need a different function. Yeah. We'll say value. Yeah, because the type of resume should be returning this so that I can do that. Right, so I have to do value is this here. And then here. Maybe this is just the wrong code. Iterator int doesn't have the field iter. Yeah, we don't have iter, we have next. Okay, so we have type checked, and now we need to do the C transpiling to C over here. So we have a two new expressions that I need to transpile, which is the delimited continuation and the thing. Unwindable. Unwindable is pretty long. Let's see. Delimited continuation. So we have token and we have body, right? So what I need to do is I need to create the so the body should be converted into a function. Oh my god. It needs to be converted into a function which captures the stuff, same as closures, puts that into a struct, creates the coroutine, passes that struct as the user data, and I guess this also part of the captured environment, the token of the delimited continuation. It might take too long. I have been thinking about what exactly I want to get to implement for a long time, but I think I have settled on this. Maybe I should think a little more. I'm just not having a lot of time, so I think I might just postpone the implementation until next time. I might come later today also to implement it. We'll see. Hello, Big Orly. Yeah, I just expect this to take at least 1 hour more, so I'm just going to pause here and continue another time, which might be today, like I said. Let's end here then. And maybe I should come up with a simpler example too. Since this is the primitive, we should like make a simpler example, which is just using that primitive instead of like doing the generator to iterator. Maybe this is too complicated for now. This also needs like capturing the move closures, which I think is not implemented yet, right? So yeah. Am I ending? Yeah, I think I just came up with the thing. Were you AFK? I think I came up with actually not the algebraic effects, but the delimited continuations as the primitive instead. So we are going to have this new constructs similar to unwindable, but it is a delimited continuation thing, which you can capture the continuation of. So it's basically similar to unwinding, but the thing that we can resume instead. Right? And then you compose the algebraic effects using the delimited continuations, contexts, and functions. Is the idea. So I have it type checked, but the code generation for C still needs to be implemented. Do I have time for playtest? Okay, sure. Let's do playtest of your game. Sure, before I end. Is it updated? Do I need to do something here? Properties. Discord DM. So I have this tunnel vision now. Needs to be updated. 13 megabytes, that's a huge game. All right. Do you have a Twitch category already? Close to light. Nice. All right, we're just going to playtest Nerdsel's game for a little bit. 99% complete. Can you be 100% complete, please? All right, written in Rust, by the way. I did not read this text. It's already ended. Wait, you have... Wait, hold on. Oh, yeah. I thought you included the editor in the demo. That would be... too much for a demo, I think. Why do you have this animation of the thing closing, but then it closes this inner stuff, but the oops is still like disappearing instantly instead of also like closing, you know what I mean? It like closes smoothly until the oops, and then the oops just disappears. Wait, it's not there? Did you not update it? Into click publish is version 015 here. Is that right? Offline. Why am I offline too? I mean, I just downloaded it, so... The version is due, but the level is not. What do you mean? Okay, do I play this? The microphone is picking up the audio, right? I'll play with headphones. Check the settings. If I have the brightness... Where is it supposed to be? Here? Show trail, trail size, show outline, outline color, the rhythm circles, show the misses. You don't update your game on Steam properly? Music offset. Wait, hold on. Can you guys read this number over here? It says negative 0.28042603. Are you sure that it needs to be this tiny there? I mean, if you set in the number... Am I supposed to be able to type the number there? Oh, wait, I am. Am I? Wait, what? Linksider. No, I think a Frostlight is my favorite one, right? The volume is also... yeah, you should just round this number. The volume is also huge. Wasn't there some audio glitch a second ago? I like this. When you hover on the music offset. There are some audio glitches that I get. What is perfect color? Telegraph color and perfect color. Oh, when we get the perfect things. The preview is the same. Alright, do I play this? Nertzel, instructions, please. Do you hear the glitches in the sounds? Sometimes. Might be my Linux issue though. You don't hear glitches? Wait, is this the new music? I don't remember this one. No, I do remember it now. So what is new exactly? I think this white circle around the cursor is new. What does it mean though? The inner circle is sometimes red. That's the new telegraphing? Or something? That's what you're talking about? Right? So right now we have the red dot in the middle. Just the cursor is new, right? 69% precision. Nice. The new stuff is not in the build. You don't know why. Alright. I don't know why. I can try later. Maybe it's like cache on the Steam. But I think usually we just download it immediately. Right? I don't know. I can try later. Verifying the integrity. I mean, didn't I download it though from scratch? When you told me, so yeah. I don't know. Alright, is there any other streamer playing Close to Light right now? No. Favorite. Follow. Weird. Maybe, wait, did you push not to the branch, but to the thing instead? To the main demo files on accident, maybe? You have the build correct on your Steam client? Alright, I don't know. Try someone else? Try Pigorly? Give Pigorly access, see if Pigorly has the correct build. Maybe you only update the Windows but not the Linux or something. Or maybe you updated the Linux and I'm using the Windows. Compatibility. No, I'm using the Linux one, I think. Try verify again. Now it's down. Now it's updating. Something is happening. Did you press something? Yeah, this is new now. I see. But I mean, what's the difference? Isn't it just different color? The new level shows in custom. Custom levels. Close to collapse, this one. Difficulty 666. You said there is a new setting? Tunnel vision. Hard. So you made this one yourself? And you have screen shake now too? Darkness absorbs you. Oh, and just stay on the edge of the circle. That's the new shape. I think there is no telegraph for the fact that it's going to be a circle or a cutout circle. I like this level. It's cool. Oh no, I'm going to lose. Boodoo boodoo boodoo. Still didn't lose. Bog. No, no. This and is what? Completion 58%. Is that like the completion in terms of length, right? I think that's new. Oh wait. I'm doing the hard, but there's only the hard version, right, at this level? You did not do the easy? What am I supposed to do here? This is impossible over there. Just the random circles on the screen? How am I supposed to know where to put my mouse there? Alright. That's cool. I'll try to beat it. Maybe off stream or some other time. Watch the video. What video? What video? Is there a video inside of the game? This one? Is that just a playthrough of it? Easy, playing without hands. Exactly, Bigorly, easy. What? This is impossible. Well, I mean, you're supposed to look for the... Like, you're supposed to really focus on the... There's no way I could do that. So I think Nurtle is just cheating here. Your touchpad does not do that? Oh yeah, Nurtle is playing on like the... You're not playing with mouse, right, Nurtle? Mostly with mouse, actually? Oh, okay. Alright. See you guys next time. I'll implement the C side of the continuations next time. Alright, bye.